Hi, and welcome back to Math 7. Our goal for today is to continue expanding expressions using what's called the distributive property. So the distributive property says that something is going to be handed out or shared to all other items. So you want to identify that value that's on the outside, which is being multiplied with the items on the inside. It's going to get handed out or shared to all the items on the inside when we use this process of expanding using the distributive property. Once we've done the expanding part of the process, we want to see if we can get the problem in a more basic, simplified version based off of, do we have like terms once we're done sharing that outside item? If we don't have like terms, the result of the expanding using the distributive property is its most basic simplified version. If there are like terms, then we should continue to combine those like terms until we get to the best possible, most simplified version. When we have a numerical expression, which was goal number 1 with our distributive property, and we take those outside items and we share to the inside items, we're going to always get things that are like terms because we started with all numbers. And all numbers, decimals, fractions, positives, negatives are like terms and they can go together. So we should continue that simplifying process after we distribute. However, when we have a variable expression, oftentimes once we take our outside item and share it to the stuff on the inside, we don't have things that match called like terms, which means the result of doing our expanding gives us our most basic simplified version. So when I'm working through these problems, I might see the directions that say expand, which tells me to take that 9 times and share. It might say simplify, which means take that 9 times and share it and see if you have matching stuff that could go together. It'll still result in this case of 54g plus 45. And it might say use the distributive property, which says take that 9 and share. So just keep your eyes open for expand, simplify, and distributive property, all to be mixed up on Get More Math. And then for this particular problem, they all mean take that 9 times and share to the leftover items. One additional example that's not in my notes, but we need to address because it's the type that we tend to mess up on, is when my outside item has a variable. And I want to take that outside item with a variable and share it to the stuff on the inside. It's the type we make the most oopsies on. So I'm taking this entire thing of 2y times, and I'm sharing it to the 7y and the negative 6 on the inside. So my first problem would be this problem here, 2y times a 7y. So I'm taking a 2 and I'm multiplying it with a 7. That'll give us our number part of our answer of 14. But then I'm taking a y and I'm multiplying it with another y. So y times y, we can write better as a power of y to the second, or y squared. So we have a 14 being multiplied with a y to the second power. Now we tend to do pretty well with that first one where we end up with something squared. It's on the next term that we tend to forget or leave out our letter for some reason. This y is now also getting shared to this second thing, which is a negative 6. So be careful. I'm taking 2, I'm multiplying it with this negative 6. When I do that, I get a negative 12, which is going to look like subtract 12 down here. Now, here's where we messed up. This y also got shared here, which means it's also here. So we have a negative 12 still being multiplied with y. Now, lots of times we leave this y out, we forget about it, so that's mistake number 1. Now, mistake number 2 is now once we get here, we want to see if we can simplify any further by combining things that are like terms. In this case, we have a term that has a y to the second power, and we have a term that has a y with no power, means it's to the first power. Since one of the y's is to the second and one is to the first, these are not like terms. They don't go together, so be careful there. All right, so on your own, you're going to finish the next page that is not completed yet in your Chapter 3 notes, which is 13, expand using the distributive property problems. Hit pause here on the video and try them on your own. All right, if you're not done, hit pause. Try them on your own first because our next quiz, you need to be able to do these without just copying down the final answer. So hit pause if you haven't done them yet. Try them first on your own. All right, number 1, we should have a negative 12u minus 20. Number 2, a negative 32 minus a 128n. Number 3, a negative 5w minus 35. Number 4, we should have a 2x squared plus 6x. All right, number 5 is kind of tricky. We're sharing an outside u to an inside item that has an n. So for the first one, we should just have a u here. However, when we did our second share, we should end up with both a u and an n. Now, I could have negative 30 NU here, that'd be perfectly fine. But you have to account for the fact that there's a negative 30 still being multiplied with a letter U, being multiplied with a letter N. Make sure you have all of that there. All right, number 6, a 54T minus 27. All right, number 7, negative K plus 9, or you might have something that looks like that, which is a negative 1K plus 9, which is perfectly fine. All right, number 8, 16M plus 6G. And then number 9 is like the one we just did right before you tried these on your own. So check. When you went S to S, did you end up here with S that is now to the second power? And when you shared your S to that second thing, did you bring over your S that's now to the first power? If you forgot that second S, you just made the mistake we tried to address, so be careful. Now you need an S on both terms. Now those don't match. One has an S to the second, one has an S to the first. So don't try to put them together any further. All right, number 10, we should have a negative 8m plus a 4k plus 6. Number 11, we should have a 5p plus 4r plus 2. Number 12, a negative 64w, a minus 12q plus 4m, and a minus 44. And then number 13, we should have a 30y plus 10y minus 20r plus 5g. All right, so our goal for today is if I'm given different expressions, either variable or numerical, can I find the ones that match in value, and can I find ones that don't match, or what are called not equivalent, right? So which ones are equivalent to each other and which ones are not equivalent. So flipping to our next available page, identifying equivalent expressions. Now, when we want to identify if things match or are equivalent to each other, we always want to think about them in their most basic simplified versions. So we want to take these 4, A, B, C, and D, and write them in their most basic simplified version. So for some of these, that's going to require us to expand using our distributive property. So we want to take each item, 4 times our 6x plus 8, get it in its most basic simplified version. 24x plus 8, get it in its most basic simplified version. 24x plus 32, get it in its most basic simplified version. And negative 2 times the negative 12x minus 16 to its most basic simplified version. Now, when you're done and you get them in their most basic simplified version, the order of the actual terms you get does not determine whether or not it's equivalent or not. It's what items do I actually get? So if I end up with 2x minus 3, but another one is negative 3 plus 2x, those are equivalent. They match. They're in a different order, but they match one another. You're looking for things that don't have matching terms to determine what's not equivalent, so be careful. All right, so this first one, letter A, we can do some simplifying here. We can expand using our distributive property to get it in a better version. So we need to do that first. We can only compare once they're all simplified. So let's take our 4 times and share it here to our 6x plus 8 to get our simplified standard form of that particular expression. So 4 times 6x and 4 times 8 to get a 24x plus 32. All right, so right now, we should be saying I got 24x positive 32. It seems to match this one, but this one is different. So right now, we think maybe letter B is the one that doesn't match, but let's go ahead. We got to simplify D to make sure only one is going to be not matching. So if I end up with 2 that don't match, that means I made a mistake somewhere in my math, and I should go back and try to find where I made the oopsie when I did my simplifying here. All right, so let's simplify down here by expanding using our distributive property. We're taking negative 2, we're sharing it to a negative 12x, and be careful down here, a negative 16. All right, negative times negative for both of these is going to give us positives, a positive 24x and a positive 32. Now, if I mess up with negative times negative here, I'm going to say that's a minus 32, and I'm going to have two things that don't match. So again, if I have two things that don't match, go back, check your work, especially the signs on your numbers. All right, 24x and 32, 24x and 32, 24x and 32. Letter B seems to be the one that doesn't match. So letter B would be the one that's not equivalent to all the others. All right, you try 2 and 3. Do your work off to the side there, get your simplified versions, and find the one that doesn't belong. If you think 2 don't belong, go back and check your work. You made an error somewhere because only one doesn't match the rest of the list. All right, let's look at these. Number 2, for all of these, except for letter D, I should have a positive 32 with a negative 16. So positive 32, negative 16. Positive 32, negative 16 with an M. And then this one is a negative 32 and a positive 16. So it looks similar, but the signs are off, so be careful. So letter D is the one that doesn't match all of the rest. All right, for number 3, we should end up with letter A being the one that doesn't belong. All the others have a negative 20 with Q and a positive 4. A negative 20 with Q and a positive 4. Negative 20 with Q and a positive 4, making letter A the thing that doesn't match and is not equivalent to the rest of the expressions. All right, so goal number 3 for today, a special application dealing with our shapes and finding area and our expanding. We're putting some things from chapter 2 with chapter 3 together here. So if we were talking about the perimeter or area of a shape, remember we have our reference page to help us. So for today, we're talking about the area or space on the inside if our shape is a rectangle. So remember from last chapter, that means we take our longer side of our shape called the length and we multiply it with our shorter side of that shape called the width. So today we're going to try to do that math, length times width, when length equals and width equals with variable expressions, which is a little bit trickier than having numbers getting replaced in. So let's look at an example. All right, we want to evaluate our length times width when length equals something and width equals something. The thing that makes these problems different from what we did in last chapter is instead of a single number for our length and width, we're given a variable expression that represents our length and our width. Now, here's where you need to be careful. For one letter, I need one item. So if my item is 2 or more terms, I have to group it all together. So be careful. So when I'm looking at this longer side, my length, since there are 2 terms here that represent one thing called the length, I have to group it all together to say, this is one big thing called L. All right, so our length is this entire math problem, 7p plus 6. All right, this shorter side, which is our width, is just an 8. So this W is just simply a 8. All right, L is out. That entire thing goes in its place. This whole entire thing is just going in here for letter L. So be careful. So L is out. 7p plus 6 goes into its place. All right, this W is out next, and 8 goes in its place. Now, I like to use parentheses for these problems because it helps me see that this is an expand using our distributive property problem. All right, we want to get this expression in its most basic simplified version to represent the area. So we take that 8 times and share it. So this 8 goes to the 7p, and it's going to go to the 6, positive 6. So 8 times 7p would just give us a 56p, plus 8 times 6 would give us a new total of 48. And it's an area, so we should have square labels in this case of square feet. All right, we're not going to get an exact number because we don't know what variable p is. We're just writing an expression to represent the total area or space on the inside, so be careful. All right, 56p plus 48 square feet would represent how many little square pieces on the inside of that rectangle. All right, let's try another one. Number 2, we want to write a simplified expression to represent the area of that particular rectangle. So length times width, where length is your longer side. So this piece, this up and down piece is our longer piece. It's our length. It is these two things. We want to group it all together because two things representing 1 needs to get grouped together. All right, so this L is the entire problem, x plus 1. All right, our width, which is the shorter piece, is just a 3. All right, L and W's out, x plus 1 and 3 go in. So this L is out. This entire math problem goes in its place, x plus 1. All right, this W is out. This 3 goes in its place. All right, from here, it wants us to write the expression in its most basic simplified version, which means to expand using the distributive property. 3 times x would give us a 3x, and 3 times 1 would give us a positive 3. Again, in this case, we want a label because it's an area problem, in this case of square inches. Good final. 3x plus 3 square inches would be an expression to represent the area on the inside of this rectangle. All right, number 3. All right, a little bit different, same idea. We want to write a simplified expression to represent the area of this rectangle of length times width. All right, this up and down piece is our long side. It's our length. Is this entire thing all together? So length is 5y minus 4. This piece, the shorter piece, is our width, which is the entire thing, 2y. All right, L's and W's out. Our 5y minus 4 and 2y go in their place. So this L is out. This entire math problem in its place of 5y minus 4. All right, this W out. This entire math problem of 2y goes in its place. All right, it wants us to write this problem, though, in its most basic simplified version, which requires us to expand using our distributive property. So 2y times 5y would give us a 10y to the second. Be careful there with your power. And then this 2y times a negative 4 would give us a minus 8y to the first. Don't forget that y. And again, we should have square units or square labels. In this case, square minus would be our good final simplified expression to represent the area of this particular rectangle. All right, flip to the back. Last couple, we want to write a simplified expression to represent the area of this rectangle. You go ahead and try this one. I'll give you a second here. They're very similar to the others. Be careful. This bottom piece is our long piece, which is our length. This side piece is our short piece, which is the width. So be careful identifying L and W. All right, our length here, or the longer side, is a 52. Our width, or our shorter side, is this entire math problem, x plus 10. All right, let's substitute in. L is out. 52 is in. W is out. The entire problem, x plus 10 is in. All right, get our simplified version by expanding using the distributive property. So 52 times x is a 52x, and 52 times 10 would give us plus 520. And our label here should be square centimeters. Good final simplified expression to represent the area of that particular rectangle. All right, the last two are a little bit different. So thing number 1 is we're talking about the largest rectangle. So I've highlighted it in red there for a reference. So we want to write a simplified expression to represent the area of the largest rectangle in this picture. Now, this side right here is our longer side called the length, right? These together represent this L. It's not just 8W. It's not just 2. It's that whole thing, or those two pieces added up. So our length would be an 8W plus that bottom section of 2. Make sure you have the whole thing, not just 8W, not just 2. All right, our width is this bottom shorter piece, which is just this 15. And now we're right back to where we were a second ago. 8W plus 2 goes in for length, being multiplied with our 15 for width. All right, to get our simplified version, expand using the distributive property. All right, 15 times 8W and 15 times 2 will give us our simplified version here. 120W plus a 30 square inches. Good final simplified expression to represent the area of that rectangle. All right, so last one, we're talking about the largest rectangle, the big red one in the picture, not one of the little ones inside of it. Our length is the longer side, which is this bottom piece, the way that it's sitting. So our length is the 12. The width is the shorter piece, right? Well, this whole way. It's not just 3G and it's not just 6. It's both of those put together. So both of these together represents this piece called the width, which would be 3G plus 6. All right, L and W out. 12 times our 3G plus 6 goes in its place. Expand to get the simplified format. Don't forget your labels in this case of square, millimeters, in this case 36G. And then 12 times a 6 here would give us our second thing of positive 72. And again, square millimeters. The final simplified expression to represent the area of our rectangle. All right, I hope that helps you attack your work for today. Have the best day ever.